Welcome to paradise. Welcome to paradise. Welcome to paradise.
Try to make that look like water because week 5 here is our water week. So let's talk first about the rainwater site flow map and volume calculations. So the first thing I want to talk about is how this connects to one of our earlier assignments, which is where we placed our site within the greater watershed. So here's the greater watershed. Here's our site. And here is the watershed of our site. So this is where understanding our watershed context really helps us directly design for our site, because the water entering our site is coming from this watershed. So when we have water entering our site, we want to know what the watershed area is, because that will tell us how much water is coming into our site. And it'll also tell us some of the characteristics of that water. Is it coming very quickly? Is this a paved parking lot that is draining water onto our site, or is this a intact forest? That makes a huge difference to the particular hydrology within our site. So when you're doing your rainwater site flow map, these are two very important features. Now, you may not have any water entering your site from off-site. You also may not have water leaving your site. Water may flow into a pond, and only in extreme events would you have an overflow from that pond. Actually, no, I think every site at some point needs to plan for the fact that you may have water leaving your site. So I can't think of a site in my mind that has no water leaving it ever. So when you're mapping, you want to map where that water is going to leave your site. So when you're doing your site flow map, you're going to do your volume calculations, and you're going to create a rainwater budget. Your rainwater budget is the amount of water that is falling, especially on impermeable surfaces. We're asking you to map the impermeable surfaces because that's water that's falling and has practically 100% runoff. Pretty much all the water falling on a roof or a concrete surface or some sort of hardscape is running off. So that's the amount of water that you have directly that you know that you can access for part of your budget. So you are going to come up with this number that's going to represent the rainwater falling on impermeable surfaces, and then for when you go into the design phase, you're going to be asking yourself the question, how do I incorporate that volume of water into my design? Now, it's very likely that you may find that your site has more water than you can handle. This is a common occurrence, and it depends in a large part where you are in the watershed. If you're located up here in the watershed, perhaps you have a much better chance of being able to handle the water that falls on your site within your site. But it's very likely that you won't be able to handle the volume. And so you're going to have to look to how you can maximize, within your design, how you can maximize features that can handle the volume of water. Now, I've seen a lot of instances in this course where people have a small, maybe suburban scale lot, and they have a house, they have a driveway, there's an accessory building, there's a patio, and there's very little room on the rest of the site to actually infiltrate the water that's falling on the hardscapes. And it becomes a challenge, and at a certain point you realize that there's no way, given the amount of space you have and the amount of hardscape or impermeable surface space in proportion to the amount of other space on the site, you find that there's no way to actually infiltrate all the water onto that site. But that's something that we want to explore. That's something we want to look at and we want to understand through this exercise. Now, many urban sites actually do not have water flowing through them, even though they are placed in a position within the watershed where they should have water flowing through them. For example, you may have a site where the entire site is built up on a pad. Many suburban sites where they've created a development and they've graded out the entire development, they have made all of the housing sites up, and they've made the roadways as the drainages. So even though, where the water's flowing on the roadways and it's not flowing on because all of the pads are raised, it's not flowing onto the housing areas. So you may find a situation like this where you have no water flowing onto your site, even though when you take that lot, you find that it is in a position in the watershed where water is flowing through. But essentially, by building a pad, they have constructed an island with which water flows around. So it can be complicated when we get into human-developed areas, especially subdivisions that are master planned, where all the grading and drainage is done prior to the houses being built. And so for each of you, you're going to be interpreting not only the natural patterns of flow, but how the human development has manipulated that water flow. So you can think of it like a little bit of a treasure hunt, trying to figure out how water actually flows through this site, and backtracking and seeing the decisions that the people that, if you're not the one who built your house, that the people who built your house or originally planned the site, the decisions they made about water flow. Okay. So the next thing we're going to talk about is the elevation view. And the elevation view is really about relative height. So again, you may have a site that has a lot of topography to it that's very clear, and there's a hill and flat area, and say you have here's your structure right here, and when we look at our elevation view, we might see if this is 0, this is +2, this may be +30, and then if we have like a tree, we may see that the tree comes up to +50. I guess we would have a 0 here. That would be our 0. So this assignment seems more clear to do on a site that has topography. And sometimes when people have a flat site, they're like, well, what does it really matter? My site's basically flat. Why do we even need to do an elevation drawing? And this drawing is also very relevant on a flat site. So I'm going to draw our same scale here. So let's say we have a site that the ground level goes from +1 to 0. You might have a 1-foot drop there. You might have a structure and a tree. Okay, but the top of the house may be at plus 15, and the top of the tree may be at plus 28. Now, these are important because the height, the relative height of the features, even on a flat site, still shows us something about the shadow cast. So a 28-foot tree is going to be very different than a 100-foot tree. And the shadow that casts. So even on a flat site, we want to see the relative height of different features. It has to do with water flow, of course. It has to do with cold air or frost drainage. It also has to do with the shadow that elements cast relative to their height. So that is why that is important. And those are my tips for the week 5 assignments. I'm looking forward. This is actually one of my favorite. I'm a water fiend, and this is one of my favorite weeks of assignments to look at because I just love interpreting the flow of water. So I wish you luck out there, and I'm looking forward to seeing what you come up with. Thank you very much.